We'll now complete section 7.4 by looking at two additional examples of solving trigonometric equations. Our first example asks us to solve the equation tangent squared x plus 2 tangent x is equal to 3 on the interval from negative pi over 2 to positive pi over 2. So we note that this equation is quadratic and should be solvable by factoring. So I'm going to go ahead first and subtract the 3 from both sides of the equation. This will move everything to one side and allow me to get ready to factor. So in factoring, we know that in order to make our first term, our tangent squared, we're going to have to multiply a tangent times a tangent. And in order to make our last term, which is a 3, we're going to have to multiply a 3 times a 1. And our signs will need to be a positive 3 and a negative 1. Now you can FOIL this back out to make sure that you have this solved correctly in terms of the factoring. So once we have it factored, we're going to set each of our terms equal to 0 and solve for our trig function. So we have one function that is going to be tangent x is equal to negative 3, subtracting 3 from both sides. And our other function will be tangent x is equal to 1, found by adding 1 to both sides of the expression. Now, for tangent x equaling negative 3, we're going to have to use our calculator and use the inverse or the arctangent function on the calculator to find that angle. And so I'm going to enter it in my calculator as an inverse tangent of negative 3. I'm going to put my calculator in radians before I do that. And we'll end up with negative 1.249. Okay, so again, I'm going to enter it in my calculator this way. And my calculator is going to give me an answer of negative 1.249. And that's going to be one solution to my equation. The other solution is going to come from tangent x is equal to 1. And so we know that the tangent is positive in the first quadrant and also in the third quadrant. So we'll have a first quadrant answer. We would also normally have a third quadrant answer, except that we are told that we only want to look on the interval from pi over 2 to negative pi over 2. So pi over 2 would take me here, negative pi over 2 would take me here, and so I really just want to focus on the first and second quadrant. Since tangent is negative in the second quadrant, there will be no solution in the fourth quadrant. There will be no solution from the fourth quadrant, and so we'll just look at our first quadrant answer. And so we know from either memory or from our chart of values that at pi over 4, tangent is equal to 1. And so that solves this first example. We have two solutions, negative 1.249 and pi over 4. Our second example asks us to solve the equation 6 sine x minus 2 equals sine x on the interval from 0 to 2 pi. And so again, we're going to take our expression and we're going to solve it for sine. So I'm going to start by subtracting my sine from both sides, which will give me 5 sine x minus 2 is equal to 0. Then I'm going to add the 2 to both sides. Remember, again, we're trying to solve for sine to get sine by itself. So this will give me 5 sine x is equal to 2. And finally, we'll divide both sides by 5. And so the expression that we're looking for is sine x is equal to 2 divided by 5. And so 2 divided by 5, you can do that on your calculator, is 0.4. So it may be a little bit easier to look at that in decimal form. Now, there is no angle that has a value of 0.4 that I know either from memory or from my unit circle. So again, we will need to employ the calculator and the inverse sine function in order to get our answer. So I'm going to enter this in my calculator as sine inverse of 0.4 and come up with a solution for that. So that's going to give me in radians 0.4115. And this is going to be one of the solutions that we'll be looking for. Now, keep in mind, we know that the sine function is positive in the first and second quadrant, negative in the third and the fourth. The 0.4115 is our first quadrant answer. So we also need to find an answer in the second quadrant. That answer can be found by subtracting this from pi. Right? Because in other words, and we're not exactly sure where 0.4115 is, but let's just assume it's here. We would have a sort of complementary angle over here that matches up to that one with the same reference angle. And so if this is 0.4115, this would also be 0.4115. In order to find our angle that goes from here to here, we would need to take the 180 or the pi and take off this reference angle. So my other answer can be found by taking pi minus the 0.4115. And that's going to give me 2.73. And so again, we have two solutions to this problem, 0.4115 and 2.73.